Hello, my name is Kashifa Saeed, and I'm excited to share a deep analysis I have done on a really important topic, which is global air quality and public health. So, this presentation will focus specifically on Canada, and we'll use data to answer some key questions about our country's air quality trends and what the future might hold. Okay, so to begin, we need to understand the global context. So this first set of visuals help us see what the world looks like. This map shows the geographic spread of PM 2.5 concentrations over the last decade. We can see, move the years through the filter here. And we can see that the major PM 2.5 hotspots persist in Asia and Africa, even as some regions have seen improvements. This line chart here allows us to track the year-over-year trends of the most of the populated countries, and we can filter the countries from here. But right now, it's showing the global trend. And this bar chart helps us quickly see which countries are the most polluted in any given year. And we can see that China in 2019, China was the most polluted. Um, so basically, this first story sets the stage by showing us that air pollution is a big global challenge. All right, so the impact of pollution is not just a line on a chart. It has a real human cost. And this next slide basically looks at the link between air pollution and mortality in 2021. So the first bar chart here pinpoints the countries with the highest number of deaths that can be directly blamed on air pollution. And then this second bar chart breaks these deaths down by the specific health causes like respiratory diseases or infections. And this helps us understand the direct serious consequences of air pollution on people's health and gives us a clear reason for why we need to act as soon as possible. Okay, now let's bring our focus to Canada. Our data shows a significant success story. Canada has achieved a huge reduction in air pollution emissions since 1990. So this line chart here displays the percentage change in emissions for four key pollutants over time, which are nitrogen oxide, sulfur oxide, PM 2.5, and volatile organic compounds, or VOC, we will call them for now. And so this success did not just happen by accident. There is a reason behind it. It was driven by specific policies and events. For example, the Canadian Environmental Provincial Act of 1999. And you will see the trend line here. You keep looking at the year, and we can see after 1999, we can see the decline in the gases. That sets the stage. And then the 2002 Canada-wide Standards for PM and Ozone Act, which led to a notable decline in pollutants like sulfur oxide and nitrogen oxide. So this light pink and purple pink line, we can see a huge decline after 2000. And then a major factor was the 2012 coal-fired electricity regulation, specifically in Ontario and Nova Scotia, which caused a sharp and sustained drop in sulfur oxide after 2012. We can see the drop here. And then we also see the temporary dip in emissions from the COVID-19. So we see temporary, you see just for some time, a temporary dip in emissions from COVID-19 pandemic in 2019 to 2020. And then we can also see a new challenge though. We see fluctuation and increase in PM 2.5 after 2018, which we can connect to the more frequent and severe wildfires that we've been seeing recently. Okay, next. Now we'll dive deeper into the provincial picture. While PM 2.5 emissions have generally gone down across the country, this chart shows us that the trends vary from province to province. So this is the breakdown of provinces. This is because the biggest source of PM 2.5, this pie chart is showing all the sources, are natural and open sources like wildfires and road dust, which are highly variable by region. We also have to remember that PM 2.5 is a serious health concern as its tiny particles can get deep into our lungs and can cause heart and respiratory problems. So this chart reveals how provinces like Ontario and Nova Scotia have seen big changes from phasing out coal, while provinces like Alberta and British Columbia have been more impacted by the oil and gas industry and the severe wildfire seasons. Next, our visual highlights one of our biggest wins, which is the decline of sulfur oxide. This line chart here shows how emissions have dropped across provinces and territories over time, and the reduction has been very significant compared to any other pollutants. Mainly because we phased out coal-fire power plants and put in place tighter industrial rules. For example, Ontario and Nova Scotia saw some of the biggest drops. However, again, in Alberta, the oil and gas industry means that sulfur oxide emissions remain a large part of their provincial total. So, sulfur oxide, we also have to remember, it's a very serious pollutant. It causes breathing issues and is a main cause of acid rain, which damages ecosystem. Next, we'll focus on nitrogen oxide. While emissions have fallen by 45% since 1990, nitrogen oxide is still a major pollutant. This line chart here shows the trends by province. We can see that the problem isn't equal across the country for sure. Alberta, again, it accounts for a massive 42% of the national emissions, and along with Saskatchewan, it has the highest per person rates. In contrast, Ontario and Quebec have the lowest. And this is largely because the main source of nitrogen oxide, as we can see in the pie chart here, are the combustion of fossil fuels, with the oil in the gas industry and transportation being the biggest culprits. Nitrogen oxide, we have to remember, can cause serious health issues like respiratory illnesses, and it can also contribute to smoke and acid rain. So this slide here, it finally shows the volatile organic compounds, or short, we'll call it VOCs for now. While these emissions have decreased by 38% since 1990, they are still a major source of air pollution. This pie chart on the slide, it shows us where they come from. We can see that the oil and gas industry and the use of paints and solvents are the top two sources, which makes up about 60%, which is a huge number of the total. And this line chart then shows us how these trends look across different provinces. VOCs are a key ingredient in smoke. It can damage lung tissues and harm crops. So continued progress in this area is very, very important. So now here, this slide, it brings it all together. This stacked area chart, it gives us a powerful summary of our success. We can see a dramatic decrease in total emissions since the 1990s. And then the pie chart, it gives us a clear breakdown of the top overall sources of these pollutants. So which is directly linking the trends to the responsible sectors. What we learned here is that while we've done a great job of reducing total pollution, the mix of pollutants have changed. Some, like sulfur oxide, have been dramatically reduced. Well, others like PM 2.5 here, and then the VOCs are still a persistent challenge. And then the pie chart reinforces that key sectors like the oil and gas industry, transportation, and the other industrial activities are the main drivers of air pollution in Canada. So our final data story, it focuses on the provincial contributions to air pollution. So this stacked bar chart here, it gives us an at a glance view of total emissions by province. It clearly shows us that air pollution is not spread evenly across Canada. We can see that Alberta and Ontario, as well as Quebec, are the top three provinces for total emissions. The colors in each bar chart reveal a lot about the regional economies. For example, the high emissions in Alberta are largely driven by VOCs and nitrogen oxide, which we know are linked to the big province's big oil and gas sector. So this visual proves that the fight against pollution is not just a national issue, but one with clear regional concentrations and unique causes. So to conclude, our presentation began by looking at the global crisis of air pollution, as we can see on this map, and which was highlighted by the striking global heat map and the top 20 countries for pollution deaths here. But our analysis also shows that the progress is possible. We can see here that progress is definitely possible. Canada has made significant progress in reducing overall air pollution since the 1990s, especially with the steep decline in pollutants like sulfur oxide. So this success proves that targeted policies and regulations definitely work. However, the battle against pollution is far from over. The mix of pollutants has shifted, and air pollution is not evenly distributed problem, as we can see from this stacked bar chart. The provincial bar chart clearly identifies Alberta, Ontario, and Quebec as key regional hotspots, each with a unique mix of pollutants tied to their specific industries. So, what does this all mean for the future? Our data suggests a clear path forward. The next steps are not about broad, general policies, but about targeted solutions based on the facts we've uncovered. A successful plan must be targeted, focusing on the largest regional and industrial polluters. It must be innovative, investing in cleaner technologies for key sectors like oil and gas, transportation, and agriculture. And finally, it must be holistic, adopting policies that addresses all the connected challenges of smoke, acid rain, and public health at the same time. This data-driven approach is our best chance to not only continue Canada's progress, but to build a healthy future for all. And this analysis was made possible by data from a variety of trusted sources. For a deeper look at the information I used, here's a list of our references. This is where I got all the data from. These are some of the some of the government policies and reports that I've mentioned in slide 3 or 4. And then here is some of the additional information about I found that is also mentioned throughout the presentation. Thank you so much.